Okay, so we're resuming our work on trigonometry and we're beginning to develop a series of formulas now over the next few videos that can be used in non-right angled triangles. So we're looking here at area of a triangle, and we've already looked at this previously, half times base times height, we all know that. Okay, but sometimes we don't have the base and the height. Sometimes we might have an angle, in which case we're going to develop a formula today that will allow us to use the angle and a particular combination of side lengths in order to find the area. It's still the same as half times base times height, but it saves us having to sort of do a lot of steps. We're going to develop that formula so we can go straight to this formula. Then we'll also look at a third formula for area of a triangle, which is useful if we have a non-right angled triangle and we have all three side lengths of the triangle, rather than any angles and rather than the height. Okay, so as I said, the trig ratios sine SOHCAHTOA only apply to right angled triangles. So what we're looking at is rules that apply to non-right angles. So the first thing we need to do before we look at area of a triangle is to understand the naming conventions we use when we're talking about triangles. And these will follow through to all the videos in the next few, sorry, all of the sequence of videos coming up. Okay, so the naming conventions are that we name the corners or the vertices of the triangle with capital letters. They don't have to be A, B, and C. They could be P, Q, R, or X, Y, Z, or D, E, F, or whatever. It doesn't matter, but the capital letters of those, whatever the chosen letters are. And then the opposite side length is referred to with the lowercase letter. Okay, so we're naming the vertex as B. And we also then refer to this angle as B. It's a bit of a shorthand. Technically, we should refer to this angle as angle ABC or CBA, but we do allow ourselves in this topic, just to save a bit of space, to talk about that as being angle B. Okay, so that would be the angle C, uppercase C, and that is angle A, uppercase A. And then the side length opposite angle A is lowercase a. The side length opposite angle B is lowercase b. And the side length opposite angle C is side length C, lowercase c, sorry. Okay, so what we want to look at here, now that we're happy with those conventions, and as I said, they'll follow through all the time, is that we want to be able to look at a way to find the area of this triangle. Okay, and we know that area is half times base times height. As I said, that doesn't change, but we want to be able to do it if we know an angle in the triangle. So let's imagine that we know angle A. Okay, let's call that angle A. Let's imagine we've been given angle A. So what I want to do, in order to be able to use angle A and to use trigonometry, I need right angled triangles. So what I do is I create, and I also need the height for the area. So I'm going to create a right angled triangle using the height. We know the height of the triangle always has to meet the base at a right angle, so therefore we know we've got a right angled triangle. Okay, so in this triangle, ACP, so I've labelled this point P just so I can refer to it easily in my descriptions. So we've now divided ABC into two right angled triangles. Okay, the other one is also a right angled triangle, but we're a bit less interested in that one right now. Okay. So we've divided into two right angled triangles. So if we look at ACP, which is the purple triangle I've highlighted, we can see that sine of angle A, sine of A, would be equal to opposite, which is H, over hypotenuse, which is B. Okay, we can't use C because C is this whole length here, so that's not useful. But what we do know in the purple triangle is we know the angle, and we know B, and we know H. Okay, so that is opposite, and this is hypotenuse. Okay, and so we're going to use sine. So sine of A is H over B, and we can rearrange that to multiply both sides by B to say that H has to be B times sine of A. So what we've now done with simply splitting the triangle into two right angled triangles and using some right angled triangle trig is we now know, we now have an expression for the height. It's B times sine of A. Okay, and so therefore when we use half times base times height, in this triangle the base is C, so the base is C, and the height is B times sine A. So half times C times B times sine A means we get half BC sine A. Okay, and so that's this here. Now the important thing is I could have labelled my triangle in a different order. If I had instead called this corner A and this one B and this one C, my formula would have turned out to be half AC times sine of B. If I had instead labelled this corner, what am I up to? This corner B, and this one A, and this one C, then my rule would have turned out to be half AB times sine of C. So the point is, it doesn't matter which letters I use. I don't want us to get bogged down in what's A and what's B and what's C. The important thing is, so we could write the formula in any of these three ways. The area of this triangle would be half times AB times sine of C, or half times BC times sine of A, or half times AC times sine of B. Okay, so the important thing is if I'm using this triangle, I'm using this angle up here and these two side lengths. Okay, so it has to be the angle in between the two side lengths. So if I don't know that angle up there, if I know this angle here, then I'm going to need, my formula will need to use A and C as the side lengths. So that's this one here. If I have to use sine of B, then it'll be half times A times C times sine of B. Okay, so it's the angle, it's two side lengths and the what we call the included angle, the angle in between them. Okay, so again, you need to let your information drive what's happening, but I wouldn't focus on trying to label things as A, B, and C. Whichever angle you have, okay, that has to be the included angle, and it's then got to be the two side lengths either side of that angle that go into your formula. Okay, so as I said, the formulas are all the same. They basically say area is half times a side length times another side length, and then times sine of the angle in between those two side lengths. So this is how I want you to think of it, okay? I don't want you to worry too much about what's A, B, and C up here. This can get confusing. There's not three different formulas. There's one formula. Okay, example 1. Find correct to two decimal places the area of the triangle pictured. So you can see this isn't labelled as A, B, and C. It doesn't matter. Okay, but what I'm identifying immediately is that I have an angle and I have the side lengths either side of that angle. So this is suitable for this formula. I've got the right combination of information to use this area formula up here. Okay. So I know the area of this triangle is going to be half times the two side lengths multiplied together, 7 times 9, times sine of the angle in between those two side lengths. We call that the included angle of 64 degrees. And then we can just put that in our calculator. Half, or 0.5, times 7 times 9 times sine of 64. Control Enter for a decimal. Correct two decimal places, the area, so 28.31, and units, it's an area, centimetres squared. Okay, question 2. Find correct to two decimal places the area of triangle ABC, where BC is 81 metres, AB is 126 metres, and angle ABC is 47 metres. So if it's angle ABC, it's centred around B, so this is essentially the angle at B is 47. Okay, so the first thing you'd need to do if you haven't got a triangle is to draw a triangle. It doesn't need to be at all to scale. I'm just going to draw out a triangle. If I call this corner B, that means that's the 47 degrees down there. Okay. Now I know that BC is 81 and AB is 126. Okay, so let's make this A and C. So this is 126 here, and this is 81 here. So the key thing is that I've got information that I need. I've got an angle with two side lengths where the angle is included between those two side lengths. So I can use my formula for area. Area is half. We multiply those two side lengths together and then multiply by sine of the included angle. Alright, so half times 81 times 126 times sine of 47. Oops, Control Enter. That is 3,732 point, what do we want? Two decimal places. Okay, so I've got my float settings set a bit low here. I think I must have been illustrating something. Would normally have them higher. If I can't see enough decimal places, I'm going to scroll up. I'm going to press Enter to copy that answer onto the next line, where I can see more decimal places, and I can see that to two decimal places this is going to be 10. But I shouldn't make that assumption from that previous line. I'm just going to increase my float settings a little bit. So click on the battery, document settings. I normally like to have it up at about float 10, particularly when we're doing financial maths. Alright, so now if we did that calculation again, Control Enter, it would show me more decimal places. Okay, units on that problem. What have we got? Our units are all in metres. This is an area, so this is metres squared. Okay, question 3. The triangle pictured has area 22 centimetres squared. So we've been told the area. Okay, so this time area is known, it's one of the lengths that is unknown, whereas in these previous examples we've been given both lengths and an angle, and it's the area that we're trying to find. This time we've got the area, we need to find one of the lengths. It's the same. Put the information into the formula and solve it for the unknown thing. Okay. Alright, so triangle pictured has an area of 22 centimeters squared. Find the value of x, correct 2 decimal places. Okay, so if I want to find x and I've got the area, I need to be able to use x in a formula for area. I know that the area formula, I need to have 2 side lengths and the included angle. So I'm not going to use the 26 because the 26 is not an included angle. If I want to use x and 4, then I can use the angle 83. Okay, so in this case, we know that area is half times x times 4 times sine of 83. Sorry. But we know the area is 22, and so we know that 22 equals half times x times 4 times sine of 83. Oh, 83. Okay, so we can get our CAS to solve for x. This is a slightly, well, probably slightly tricky rearrangement for most of you to try and do it by hand to avoid solving, so I'm just going to get my CAS to solve. Just to be clear about this, I find students really struggle with this idea. In the previous 2 examples, there was no need for us to solve an equation in our CAS. Solve, the process of solving means to get the unknown on its own, and that's already done here. We've got the unknown on its own, and then all we need to do is just type that into our calculator to work out what that unknown is equal to. So there's no solving, we've done the solving, or it's already solved, okay? Similarly here, the unknown is already on its own. We've solved for area, we're now just getting our CAS to work out the numerical value of the area, just to actually work out what that is equal to. Whereas here, we haven't solved for x, okay? X is not on its own. We need to solve for x first. So that's why here we're going to need to use solve. Whereas in the previous ones, we don't need to use solve. It's already solved. We simply just type that expression in and work out that that equals this. Okay. So we need to solve in this instance. 22 equals half. I'm just going to type that as 0.5. If I want my answer as a decimal anyway, I may as well just type 0.5. It's quicker. 0.5 times x times 4. Oops, sorry, times 4. Times sine of 83. We're in degree mode, so it understands that the 83 I've just typed is an angle in degrees. And then we're going to need to solve for x, so comma x, and x is approximately, what do we want, 2 decimal places, 11.08, and it's a length, and the units of that length are centimetres. Okay, so it's the same formula, it doesn't change, it's just that this is where the unknown is here. Okay, whereas in these problems, the area was the unknown thing. That's all that we're changing. Okay, I mentioned at the start of the video, we know area of a triangle is half times base times height. We also now know that another way we can find area of a triangle if we know about an angle is to use half times, multiply 2 side lengths together and then multiply by sine of the included angle. And then I'm going to introduce a third formula for area here, which is called Herons formula. And this is used to find the area of a triangle when all 3 side lengths are unknown. Okay, and so the formula is this. It is area is equal to the square root of s times s minus a times s minus b times s minus c, where a, b, and c are obviously the 3 side lengths, and s is this quantity here. We add up the 3 side lengths and divide by 2. Okay, so you're going to need to do this bit first, work out that, and then you put that into your formula, along with A, B, and C from the triangle. Okay, so we work out the S value first, which is adding all the side lengths together and dividing them by 2. It's called the semi-perimeter, half of the perimeter. That's why we use the letter S. Okay, so the perimeter would be A plus B plus C, and obviously dividing it by 2, we're getting half the perimeter. Okay, so find correct to 2 decimal places the area of a triangle with side lengths of 8, 10, and 13 centimeters. So we first work out what S is, the semi-perimeter. We add together the 3 side lengths and divide by 2. So that is 33 divided by 2, or as a decimal, if we want, that's going to be 16.5. Alright, and then we can work out the area is going to be the square root. Now make sure your square root extends across the whole thing that you're square rooting. if it stops, if you write something like this, you know, 16.5 times something else, you're not square rooting this something else out here. So make sure that you write what you mean. Okay, mathematics is a precise language, and it's important that what you write down is actually what you mean. Alright, so area is going to be the square root of, it's S, which is 16.5, times S minus A, which is A is just one of the side lengths, so it doesn't matter what order we do these in. These could be in any order. You could do that times that times that, or that times that times that, or that times that times that. Okay, it's always going to be the same. So you just need to do the S value subtract each of the side lengths. So I'm going to do 16.5 minus 8, which is 8.5, times 16.5, which is S minus 10, that's 6.5, and then 16.5 minus 13, which is 3.5. Okay, so our area is the square root of, 16.5 times 8.5 times 6.5 times 3.5. As I said, it wouldn't matter what order you put those in. If we wrote this as, you know, 3.5 here times 8.5, the order that you multiply things doesn't matter, it still gives the same thing. Okay, so we want area to 2 decimal places in this instance, 56 that will become 49. And the units of length were centimetres, and so the units of area are centimetres squared. Alright, example 2 for Herons formula. A triangle with area of 30 centimetres squared has side lengths of 8 centimetres and 12 centimetres. Find correct 2 decimal places the 2 possible values for the lengths of the third side. Okay, so this time we've been given the area, okay, and we've been given 2 of the sides. Okay, so let's say that's A and that's B. So we would also have A and B to work out part of S. So the only unknown in the problem is going to be C. Okay. So we should be able to solve for C. It's going to be a slightly messy equation, but we just need to be patient with what we've got. Okay, so let's work out S first from what we know. We know S is going to be 8 plus 12 plus, there's an third side that we don't know, divided by 2. Okay, so that is 20 plus C divided by 2. Yes, if you want, you can write that as 20 divided by 2, which is 10, plus C on 2. Okay, I'm just going to leave it as that personally. It's up to you. Okay, so then we know that our area is equal to S. I'm just going to make a bigger square root. S, which is this thing. So it's 20 plus C over 2 times S minus A. So that is 20 plus C over 2 take away. Now I've sort of said A is 8 and B is 12. Doesn't matter, I can switch them around if I want, but same thing. Times 8, and then we've got 20 plus C over 2 minus 12. Again, extending out my square root because I want it to be over all of this, and 20 plus C over 2 minus C. Okay, so whilst it is a really ugly equation, oh, and the last thing we also need to do is we know that the area is 30, so that's going to go in there. Okay, and so therefore we've got a really ugly equation, but there is only one unknown in the equation. Yes, it's in lots of places in the equation, but the fact there's only one unknown means we can solve it for C. Well, our cats can solve it for C. So menu 3, 1, we're going to have 30 equals square root of 20 plus C over 2 times bracket, same fraction again, 20 plus C, oh sorry, I missed the 2, 20 plus C over 2 minus 8 times fraction 20 plus C over 2 minus 12, there's that bracket, times, nearly there, control divide, 20 plus C over 2 minus C. And we solve that for C. We press I'm going to press Control Enter to get my answer as a decimal. Oh, sorry, I forgot to do comma C. We want to solve for C. So outside of the square root now, comma C. Sorry. Control Enter to get as a decimal. Okay, so it says I want to give the two possible values for the lengths of the third side. Okay, so we actually don't have enough information here to uniquely define the triangle, but there are only two possible values. Now my CAS has given me more than two values here, but you'll see the first one is negative 18. Now C is a length, so it's not negative. The next one is negative 7.6, it's also not that. So if we scroll to the other end, there are two positive solutions, okay, and we see that C is approximately equal to, and what do we want? Two decimal places, either 7.62 centimeters or 18.92 centimeters. Okay, so if we had a triangle with side lengths of 8, 12, and 7.62, it would have an area of 30. But equally, if we also had a triangle with side lengths of 8, 12, and 18.92, that would also have an area of 30. So if you think about, that, if C was 7.62, that's the shortest side length, okay? So you're getting sort of a kind of fat triangle with, 7.62 and 8 and 12, whatever, okay? Whereas if C is 18.92, so nearly 19, you're getting a really long, thin triangle. Okay, so even though this is a really big triangle, 18.92, this is 8 and this is 12, you've got that area spread over a long thin area where this is going to be a sort of stumpier, fatter thing, and so they have the same area ultimately. Okay, exercise 18D is looking at area of a triangle, so where we have non-right angled triangles, and we're given combinations of information that don't make it easy for us to use half times base times height. So we either want to use Herons' formula if we have 3 side lengths, or the formula involving sine if we have an angle and 2 side lengths. The angle must be included between the 2 side lengths.